Hello everyone. Today we want to talk about the transformers and what is the transformers in power systems. So normally the transformers is used for the changing of the voltage level. So we have one voltage level and we want to increase that voltage level, so we use the transformers. So these are transformers that we have in the circuits in the smaller scale, and with the same concept we can have the transformers in the power system. So here we can see this is a three-phase power system that you can see in the power grids. So first, what is a transformer and why we use a transformer? So normally in generation units, we have very high current and high power for generation, and we should send that power to the consumer in the line distance. So because we have the transmission line, we have a lot of losses in the transmission line, and the losses in the transmission line is regarding the current. So if we have high current, so we have a lot of losses, and also we have a lot of voltage drop. So before sending the power to very far locations, we increasing the voltage by a step up transformers. So when we increasing the power, because when we increasing the voltage, because the power is constant, the current will drop a lot. So we will avoid having further losses in the transmission lines. So here we can see we increasing 11 kilovolt to 400 kilovolt by transformers. We send the power, and in the consumers we decrease that 400 kilovolt to 33 kilovolt, and we sending to the consumers. So in the home also we have the transformers in the distribution systems close to houses. So we have the three-phase transformers. For example, we have 11 kilovolt to 400 volt transformers everywhere, and we have the three-phase systems, and from that three-phase systems we connect houses for every single phases to these lines. For example, house number 1 is connected to phase B, house number 2 in phase Y, and house number 3 to phase R. And we have, for example, a factory with 3 phases that is connected to 3 phase. So how is the working principle of one transformer? So when we have one core, or when we have some winding, normally when we send some current, some variable current to that core with a lot of windings, it produces some flux. And if we have another winding, that flux can be received by the secondary. And because if we don't have any core, we will have very, very high losses. We have a core, and the flux will go through this core and will receive to the secondary, because the EMF is equal to N A delta B to delta T, and exactly same thing will receive in the secondary. If we divide these two equations to each other, we'll resolve this one. Voltage in secondary divided by voltage in primary is equal to the ratio between the number of turns. Then we can have this equivalent circuit that is normally we use for analysis. So we have the primary source, and the NP to NS is the number of turns, and then we will have the voltage in the secondary and the current in secondary. So we can see the V in primary divided by V in the secondary is equal to current in the secondary divided by current in the primary. So how is the transformers in three-phase? It's exactly the same principle, but we have 3 different windings. So winding A, B, C, and we will have the 3 phase from the output of them. Exactly same principle. But the point is that normally in the transformers, because we have a lot of windings, 1000 turns, 2000 turns in the primary and the secondary, and we have a core, we have a lot of losses in both sides. So this is the equivalent circuit for the transformers for the second analysis. So if we want to have the real model for the transformer, we should consider R and X for the primary windings, R and X for the secondary windings, and then we will have the parallel R and X, B and G for the equivalent circuit for the core.